Hey, what's up? Let's do some math today. In this video, let's talk about an intro to radicals and square roots. Now, I've been dealing with these for a while now as a teacher, and students, for whatever reason, get really intimidated by this symbol right here. That's technically called a radical, and there's several different variations of them, but more often than not, when we're dealing with them, we're dealing with square rooting. And so what I want to do is I want to talk about what they are and what they aren't. And to get started, I want to talk about like an analogy, and we'll kind of talk about what they aren't and then build our way to what they are. So it's really what it is, what they are, is it is a way of having with multiplication. Okay? Now let's think about what just half means. So for example, if we were to take a look at the number 8 and we wanted to half it, we all were like, hey, that is 4. Because what we can do is we can take 8, 1, 2, 3, 4, 5, 6, 7, 8, and we can break it into two groups of 4. And we add those two groups, we now get 8. Well, we're doing the same thing with square rooting, except what we're doing is instead of having a multiplication sign here, or so an addition sign, we want a multiplication sign. And so what we're looking at is a number like, let's say, hey, 16, and we want to break it down into two equal factors. We want the factors to match up, but we're not adding them, we're going to multiply them. And so that gets me, it's going to take a while for us to get used to it, and the way it kind of works is we have to know which numbers are perfect squares and kind of how to break things down to perfect squares and stuff like that. And one thing I really want to get across right now is what they aren't. And what they aren't is just straight up having. Okay? It's having with multiplication. There's a big difference there. So something I see a lot that is a big no-no is a lot of people think the square root of 10 is equal to 5. And I cannot stress this enough. That is not how that works. Okay? What we're looking at we're having with multiplication. We want to break a number down into two factors that are the exact same. Okay? Now, let's talk about a couple big ideas related to square roots. So first of all, we have two types of problems. So one type of problem we're going to see here is this. Square root of some number, like 4, is going to equal something. If this is the case, this is what we call the principal square root, which I'm just going to abbreviate principal SQ, square root. Oh, and then let's put R. All right, so PSQR. We're only going to get one answer from this, and that's sort of the big takeaway. So this only works when we're dealing with positive numbers. The second type of problem we're going to get is something like this. X squared is equal to 4. Now what this means is that we're taking this x and we're multiplying it by itself 2 times. We want it to equal 4. When we take the square root to kind of crack open the problem and to solve it, we will have 2 answers. So we could have just regular old 2, which would work. Or if we wanted to, we could also plug in -2 and -2, and then that would work. So this is kind of like a technical thing with math. If you just see the square root of 4, that's going to be one answer. X squared equals something, and like you're introducing a variable, now you have 2 answers that could work for it. It could be 2, and it could be -2. Okay, so now let's talk about how we're going to do this. So, we're eventually going to talk about fractions and decimals. So, big thing that we need to know are just what we call perfect square numbers. And those are numbers that help us, or that are the result of multiplying these numbers here by themselves. So, for example, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Now, at this point, let's take a little break and let's talk about why they're perfect square numbers. Watch this. So we'll take a 1 by 1 square and show it like this with a dot. Now, let's make a couple more dots and make it a 2 by 2 square. How many do we have there? We have 4. Now, let's go with 3 by 3. See how we're continuing to maintain this square shape, and what we're doing is we're taking the total amount there. That's why we call them perfect square numbers. So keep going. 4 squared is 16, 5 squared is 25, 6 squared is 36, 49, 64, 81, 100. At this point, you should be fairly familiar with those. But now, when we get up to 11, you got to get familiar with that one. 121, 12 is 144, 13 is 169, 14 is 196, 15 is 225, and 16 is 256. If you have these in your back pocket, if you have these memorized, it's going to make your life a lot easier, because these are some tokens that we need to keep finding when we have problems. And so, for example, we take the square root of 144, we just have to know that's equal to 12. And a lot of the problems you're going to see are just going to be variations of these numbers right here, different combinations of them. So for example, the last thing I want to show you is just how this might work with like fractions and decimals. You might see a problem that looks like this. Square root of 9 over, let's go with 64. What we can do here is apply the square root to just the numerator and just the denominator. And as a result, simplify both of these. So square root of 9 is 3. Square root of 64 is 8. So square root of 9 over 64 is just 3 over 8. All right, let's do another example. Let's say we have the square root of 121 over 4. We can look at just the numerator and denominator and realize that that's 11 squared, so it would be 11, and 2 squared, which is 2. We box it, we walk away. With decimals, it could be something similar. Now we got to be careful. So if we take the square root of something like 1.44, we essentially just look at it and think, what's the square root of 144? That would be 12. But since I have 2 decimal spots here and I'm multiplying two numbers together, it's going to be 1.2. So I have 1 decimal spot after each number for a grand total of 2. It could also get a little bit trickier when we have more zeros in front or behind, but odds are if you're seeing decimals and we're expecting to get a nice clean answer, it's going to be variations of this. So we might see something like 0.81, and then this is going to be 0.9 as your answer. So that's an introduction to square roots. Good luck on your practice, and let me know if you have any questions.